Okay, students, so we're now here in the third part of the video. We were given the short leg, we were given the hypotenuse. Now, what if we're given the long leg? And this is the trickiest part. And why would I try to trick you guys? I don't know about tricky, but I would say difficult. All right. So, let's just do it one way like this for fun. We don't know the short leg. We'll call that x. And if we don't know the short leg, and we call it x, that means the hypotenuse is 2x. All right, we're going to do brute force and use Pythagorean theorem one time. We're really going to have to use a lot of muscle. All right. So, 25. 4x squared. All right, did you feel how much muscle we had to use to make those computations? Subtract x squared from both sides. 25 equals 3x squared. Divide by 3. I'm going to swap the order. X squared equals 25 over 3. Now, do the square root, which makes the square root of 25 over the square root of 3. So x equals 5 over radical 3. And then remember, we got to rationalize the denominator. So the short leg equals 5 radical 3 over 3. 5 radical 3 over 3. And that means times that by 2, the hypotenuse would be 10 radical 3 over 3. All right, that was a lot of muscle. That was hard, all right? We're never going to have to do that again, don't worry. But that's a pattern, that's a relationship. That's what we would do if we used brute force on 30, 60, 90 triangles. However, there is patterns. All right, so we can relate this back. Let's extreme close up right here. We can relate this back to 45, 45, 90. I was multiplying by radical 3 over 3, all right? Or I was dividing by radical 3, but we have the rationalized denominator, all right? So these are the same rules, just presented differently. So over here, in this one, I'm given the long leg. Same thing, I always want to find short leg ASAP. Find it ASAP. So to get to the short leg, I can think, am I multiplying by radical 3 over 3? Or if there's a radical 3 in the answer, I'm dividing by radical 3. In this case right here, I'm going to use this one. So the short leg is 12 radical 3 over 3, which becomes 4 radical 3. All right, so this is the harder one. This is the goofy one. And the hypotenuse, then you just double. Times it by 2 is 8 radical 3. All right, so you can see we used a lot less muscle on that one. We just kind of related it back to the rules. But here, let's still go ahead and apply them. All right, so let's even write that out. Let's write short leg equals long leg radical 3 over 3, or long leg over radical 3. Same thing, just one has a rationalized denominator. And number 1, I'm going to use this first one because there's no radical in the long leg. So it's just going to be 6 times radical 3 over 3, which is 2 radical 3. And then I'm going to multiply by 2 to get the hypotenuse, 4 radical 3. Cool. Now over here, notice in this one I have a radical 3 in my long leg. So I'm going to use long leg divided by radical 3, which is just 6. So you're basically just removing the radical 3 in this version, which makes sense if you think about when you were given the short leg and hypotenuse in earlier problems. And then that's just 12. All right, so we're using rules, we're using logic, a lot of fun stuff going on right now. Number 3 is like number 1. We're going to use the same rule. You're going to be multiplying by radical 3 over 3. So I'm going to get 2 radical 3 over 3. And it can't be reduced. That's it. And then to find the hypotenuse, you always just multiply by 2. So it's going to be 4 radical 3 over 3. What's really good about doing these problems is that's really building our number sense. It's getting us comfortable with numbers. And that's good life skills to have. In this one, we have a radical 3 in our long leg. So I'm just going to divide by radical 3. It's 2. And to find the hypotenuse, I'm going to multiply by 2 and get 4. Wow. All right. So in words, so we'll say long leg is x. Short leg equals the long leg. I already wrote it above, radical 3 over 3, or like that. And then, so that means regardless of what I write or the rule I use, I'm going to present it like that in terms of x, because it has to have a rationalized denominator. It's just which version gets us there quicker. And then the hypotenuse is going to be 2 times the long leg, radical 3 over 3, or 2 LL radical 3. So and over here, 2x radical 3 over 3. So there's 3 different versions of the rules. They're all the same technically. It's just which way are you thinking? Are you multiplying by radical 3, dividing by radical 3? Are you giving the hypotenuse? Are you giving the short leg? So on and so forth. A bunch of different combinations. All right, we're just going to do a few problems. Finish these notes out, practice and refine our skills. All right, so here, this is the long leg. We're given the long leg, and I have the rules written right up here. This is going to be a great time to multiply by radical 3 over 3 to find the short leg. So it's going to be 15 radical 3 over 3, or 5 radical 3. And then to find the good old the hypotenuse, just multiply by 2. So the hyp equals 10 radical 3. This is a good one right here. And the next one, because we haven't seen this in a while, we're given the short leg. In my opinion, this is the easiest one. You just multiply by 2 to get the hypotenuse, 28. To get the short leg, you multiply by radical 3. So it's 14 radical 3. That's the long leg. Find the value of the variable. 2 more problems. Just x. We don't even have to find the hypotenuse here. So this is the short leg. Remember to go to the long leg. You multiply by radical 3. So it's going to be radical 3 times radical 3, which is just regular 3. Neat. And then this one right here, realize this problem is an equilateral triangle. So we can just focus on one of these. Short leg is 2, hypotenuse is 4. So they used h here as the height. So I guess we got 2 h's. Awkward. But that's just going to be 2 radical 3. Because that was the long leg. Alright. And that's that for special right triangles. You guys get to do a really fun quiz tomorrow.